The most powerful warship ever built, USS Gerald R. Ford, a $13 billion aircraft carrier, driven by two nuclear reactors that can run for about 20 years without refueling. On paper, that sounds like total freedom, unlimited range, unlimited time at sea, a ship that never needs gas. But right now, about 150 miles off the coast of Venezuela, Ford is only 72 hours away from becoming a $13 billion floating decoration. Not because the reactors are failing, because she is running out of jet fuel. The reactors can move the carrier forever. They can power the radar, the lights, the catapults, the water plants, everything. But they cannot power the aircraft. And without aircraft, an aircraft carrier loses the main reason it exists. Ford carries around 75 aircraft, fighters, early warning planes, electronic warfare jets, and helicopters. They all burn JP-5 jet fuel, and Ford's fuel is running low. This is day 28 of counter-narcotics operations. The air wing has been flying non-stop. Combat air patrols, intercepts, tracking ships linked to smuggling routes, intelligence reports, shore lookouts working with traffickers. Everything is coordinated, and the pace is brutal. Ford's JP-5 tanks are down to about 15%. That means only a few days left. They are burning around 150,000 gallons per day. That is roughly 3 days until the flight deck becomes useless. In 3 days, every FA-18 Super Hornet becomes a $70 million lawn ornament. 75 aircraft. Around $5 billion in metal that can't do its job. The closest American port is Naval Station Mayport, Florida, about 1,500 miles away. That is a week round trip, a full week. And during that week, drug traffickers would move freely. So, Ford needs a solution, and that solution is coming toward her right now. USNS Supply, a civilian crewed ship carrying about 1 million gallons of JP-5 just for Ford. But there is a problem. To transfer that fuel, you have to connect two massive ships while both are moving. They must travel together at about highway speed for hours. For more than 4 hours, both ships have limited ability to turn or react. That is why this job is so dangerous. If you feel proud of the sailors and the civilian mariners who do this so the Navy can operate worldwide, type "proud" in the comments. Because today we are exposing the biggest myth about nuclear carriers, the idea that nuclear power means unlimited operations. We are going to show the mega replenishment that keeps them fighting, the hard choice between refueling and launching fighters, and the moment Ford had to do both at the same time. This is how logistics defeats geography. Let's break it down. Here is the lie. Nuclear carrier equals endless mission time. The reactors last for decades, so the ship can stay out forever. Total energy independence. Wrong. Ford has two Bechtel A1B nuclear reactors. Each one produces far more power than older carrier reactors. Together, they make enough electricity for a city of around 100,000 people. They can run for about 20 years before the next nuclear refueling. Ford never needs diesel fuel. She never burns F-76 fuel oil like older ships. The reactors power propulsion, radar weapons, and the electromagnetic catapults that launch jets. The reactors also power desalination systems that can turn seawater into around 400,000 gallons of fresh water per day. That fresh water supports everything: showers, cleaning, cooking, and drinking. The ship's kitchens can cook around 18,000 meals every day for about 4,500 sailors. So yes, nuclear power can keep the ship moving. It can make fresh water. It can run the systems, but it cannot make food. And it definitely cannot make jet fuel. Ford's aircraft include FA-18 Super Hornets, E-2D Hawkeyes, EA-18G Growlers, MH-60 helicopters, and more. Every single one depends on JP-5. A single fighter sortie can burn around 2,000 gallons of fuel. In intense operations, the air wing might fly 75 to 100 sorties per day. That means daily fuel use of 100,000 to 150,000 gallons. Ford can hold roughly 3 million gallons of JP-5. At 150,000 gallons per day, those tanks run dry in about 20 days, and the Navy does not allow the carrier to go below emergency reserve, usually around 15%. So in reality, you have about 15 to 18 days before fuel becomes a crisis. That means something very important. A nuclear carrier with reactors that last 20 years still needs a gas station every 2 or 3 weeks. Not for the ship, for the aircraft. And without aircraft, an aircraft carrier is basically a giant, expensive cruise ship with missiles. Fuel is not the only problem. food matters too. Those 4,500 sailors eat about 18,000 meals every day. Fresh milk is gone in a few days. Fresh vegetables might last a week or two. After that, it is frozen food and canned food. And here's the truth nobody likes to say out loud. Bad food hurts morale. Low morale leads to mistakes. Mistakes at sea can kill people. So the brutal reality is simple. Nuclear reactors provide range, but resupply provides combat power. The reactor powers the ship. Logistics powers the mission. This is why USNS Supply exists. Supply is not a warship. She is part of the military Sealift Command. That means she has a civilian crew, professional merchant sailors. No Navy ranks, no medals, no spotlight. But they may be doing the most important job in modern naval warfare. Supply is a fast combat support ship, built to run at around 25 knots. That matters because the carrier strike group moves fast. If the supply ship is slow, the carrier has to wait. Waiting makes you predictable. Predictable makes you easier to track and easier to target. Supply is about 754 feet long and displaces around 48,000 tons when loaded. Her cargo capacity is huge, millions of gallons of fuel, plus ammunition, plus food, plus spare parts, and about 1 million gallons on board right now is meant for Ford. This is not just refueling. This is underway replenishment, also called UNREP. And this is a mega UNREP. Multiple stations working at the same time, fuel plus cargo transfer, while both ships move. Roughly 160 civilian mariners are about to do one of the most dangerous logistics operations on Earth. Not for glory, not for fame, because it is their job. Without supply, Ford's mission stops. Soon the ships raise signal flags. Romeo flags show replenishment operations. Then Bravo flags, bright red, meaning dangerous cargo is being handled. Supply holds a steady course at about 13 knots. Ford matches speed and carefully slides alongside. The gap is about 140 feet. That is close, very close. The conning officer gives constant instructions. The helmsman has to fight the Venturi effect, the invisible suction created when two huge hulls move near each other. Then, the real work begins. Teams set up multiple transfer stations. A civilian mariner uses a strange tool, an M14 rifle. A line-throwing kit is attached. The rifle fires a rubber projectile that drags a thin line across the ocean to the carrier. A $13 billion warship is connected to a supply ship with a method that looks like it came from the 1960s. Why? Because it works. In wind, salt, spray, and chaos, it still works. Soon, heavy lines are pulled across. Span wires are tensioned with massive force. Then the fuel hoses slide across, thick steel-reinforced hoses about 7 inches wide. Each probe locks into the carrier's receiving station. Valves open. Fuel starts moving. Each hose can move thousands of gallons per minute. With multiple stations running, the combined flow can reach huge levels. For safety, they do not run maximum. Even then, fuel moves fast enough to fill a car tank every few seconds. While fuel flows across the ocean below, helicopters lift off above. This is vertical replenishment, called VERTREP. Helicopters shuttle pallets of missiles, bombs, spare parts, and food. Each load can weigh thousands of pounds. Pallets swing under the helicopter as it flies just over the sea. Now picture it. 2 ships, around 4,660 people total. More than $15 billion in assets, moving at 13 knots, connected by cables under deadly tension, pumping explosive fuel, moving heavy ammunition through the air. For the next 4 hours, they cannot stop. Then, 90 minutes into the operation, Ford gets a radar contact, unknown aircraft, bearing 180, range 80 miles, speed 400 knots, closing fast. On Ford's deck, 2 FA-18 Super Hornets are already positioned for Alert 5 launch. That means they can launch in 5 minutes. The pilots have been sitting ready for hours. The air boss calls the order, prepare to launch. But below those aircraft, fuel is still flowing. Multiple hoses are still connected to supply. There is still around 200,000 gallons left to transfer. The operation is not finished. An emergency breakaway takes time, minutes. And the aircraft is coming fast, so Ford faces an impossible choice: stop refueling to launch fighters or keep refueling and risk delay. The captain makes the call: launch the fighters, continue the replenishment. Jet engines roar, deck crews move fast, holdback bars lock. The catapult officer signals, catapult 1 fires. The electromagnetic system throws 30 tons from 0 to 165 miles per hour in about 2 seconds. The entire ship shakes. A fuel hose jumps. The span wire flexes. Tension spikes. The connection holds. Catapult 2 fires. Another violent shock. Hose jumps again. Still holds. Both fighters launch and climb to intercept. Fuel continues pumping the entire time. This is exactly what the Ford class was built to do. The unknown aircraft turns out to be a coastal patrol plane. It gets close, watches the fighters, and turns away. UNREP continues. 3 hours later, the job is complete. Total transfer, about 1.1 million gallons of JP-5, pallets of ammunition, around 35 tons of fresh provisions, real vegetables again after weeks at sea. Then the final hose disconnects. The last pallet arrives. The ships begin separation. Ford speeds up to 16 knots. The gap grows, 200 feet, 500 feet. Supply plays loud music over the speakers, a tradition for breakaway. Today the song is Born to be Wild. Sailors on Ford hear it. Some laugh, some curse because they are trying to sleep after watch. But everyone understands what it means. Replenishment complete. Mission continues. Supply turns away to the next customer. Ford turns into the wind to recover fighters. The flight deck is alive again. The air wing is back in business. So how does a nuclear carrier that never needs fuel still depend on a floating gas station? Because nuclear power runs the ship, but logistics runs the war. Ford can cross oceans without stopping. The reactors can run for decades, but aircraft cannot fly on nuclear power. Sailors cannot eat reactor coolant. Missiles do not appear by magic. Every real combat capability depends on supplies. JP-5 in tanks, missiles in magazines, food in storage, spare parts in warehouses, and well-rested sailors who trust that the ship can keep fighting. Other nations have aircraft carriers too. France has Charles de Gaulle, nuclear-powered. Britain has Queen Elizabeth-class carriers. China is building more carriers, but none match the one thing that truly creates global reach, the logistics tail. Without fast support ships, without global supply planning, without crews willing to do dangerous UNREP operations far from home, a carrier cannot stay out long. Most nations stay near their ports. America does not. The United States has a large fleet of military Sealift Command replenishment ships, floating supply bases across every ocean, civilian crews supporting military power thousands of miles from home. This is the force multiplier nobody talks about, the network that turns a regional navy into a global navy. As long as supply can find Ford, Ford can stay on station. As long as fuel hoses can connect every few weeks, the mission continues. As long as civilian mariners and sailors can do this job in bad weather, at night, under stress, with explosive cargo, America can operate anywhere. Yes, the nuclear reactors are amazing. They power the catapults, they run the radars, they keep the ship moving, they keep the lights on. But they do not create dominance. Dominance comes from the willingness to do hard things, pump explosive fuel between moving ships, fly cargo through the air, launch fighters while still connected, accept risk because the mission demands it. Next time you see USS Gerald R. Ford operating off Taiwan, in the Persian Gulf, or in the Caribbean, remember this: she is not there because she has nuclear reactors. She is there because somewhere over the horizon, a ship-like supply is ready to connect hoses and pump 1 million gallons of jet fuel. The reactor powers the ship. Logistics powers the mission. That is why America can operate in every ocean on Earth. Hit like and subscribe for more content about the hidden systems that keep American naval power alive worldwide. The reactor keeps the lights on. Logistics keeps the mission alive.